Mm, Hello everyone, this is Gafab Sawile, a student at Makerere University. We are back again onto our project, and remember we are solving the problem of physical trading. So as we solve this problem, we are going to move away from physical trading to e-commerce or online trading. That's what we are trying to present, and this time around I'm going to present about an environment and the different things that will come later on after this. So let me first go through the properties of the environment. But before that, according to my research, an environment in artificial intelligence is the surrounding of an agent. So we have different properties of environments, and number one, we have a full observable environment. So when an agent sensor is capable or to sense or access the complete state of an agent at each point in time, then it's said to be in a full observable environment. Then we can also have a competitive environment, where an agent is said to be in a competitive environment when it competes against another agent to optimize output. Then you also have a multi-agent environment. An environment involving more than one agent is said to be a multi-agent environment. Then you also have a dynamic environment that keeps constantly changing itself when the agent is up with some action. So for my project, I will be working with a full observable environment because the customers need to fully view whatever is being sold to make appropriate decisions. In that, when the customer goes on the website to order for the different kinds of products they want, they need to fully observe whatever is being sold. Like, in order to make the appropriate decisions, they have to view whatever is posted, whatever is available on the market to be sold, so that they can make their decisions. Then we can also deal with a multi-agent environment, because now this is an online trading platform where different people across the world will be coming to order for different products of their choice at once. So we shall be dealing with many people at once. So that's why you can also deal with a multi-agent environment. So those are the best two properties of the environment that I chose to work with. And then next to that, we have the agent. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. A sensor is just a device that detects the change in the environment and sends the information to another electronic device, and actuators are the components of machines that convert energy into motion. So we have also different types of agents that we can deal with in our project. We have the utility-based agents. These choose actions based on a preference. Just like for our case, we can still deal with the utility-based agents, because like for someone to come and order for any product online, their desire of course is backed up by the preference. What someone chooses or what someone likes is the driving force that will make him or her to choose any product of their choice. So that's why we are going to talk about the utility-based agents, because someone will only order for a certain product if it's what is desirable to them. Then a learning agent in AI or artificial intelligence is the type of agent who can learn from his or her past experience or has learning capabilities. A case for an example in this case can be like for someone who is coming to order for a product, and this is not going to be a one-time event, it's a repeated process. Someone will keep on coming over and over. Maybe if someone made a mistake in the first search, remember this is going to involve some voice recognition, where someone can search by just mere mentioning the word of the project, the name of the project, the product, and then is in his position to access it. So you can learn from the past mistakes, that if maybe you made a mistake in your ordering, then this time around you're in a position to learn and correct your mistake. And then next that, we are going to talk about the dataset description for my project. I got it from Kaggle. Remember, we are transforming from physical trading to e-commerce or online trading. So according to my dataset, e-commerce has become a new channel to support business development. So through e-commerce, businesses can get access and establish a wider market presence by providing cheaper and more efficient distribution channels for their products or services. So e-commerce has also changed the way people shop and consume products and services. many people are turning to their computers or small devices to order for goods which can easily be delivered to their homes. So that's just in accordance to our project. Someone is in position to come and order for the products of their choice, and then the one who deals in such products is in position to deliver the different places to the different destinations of the customers. So that's the data set I'm going to work with. I got it from Kaggle, and here is the link. Then talking about how we can apply informed and uninformed search in our project. First of all, informed search. So these informed search algorithms have information on the goal state which helps in a more efficient searching. So some additional information is also present which makes it easier to find a product of interest decided upon by a given customer. That you are going to make a search about something you already have an idea about. If someone comes to order for a certain kind of product, they may be aware from past experience that it's available and is being sold on that particular website. So informed search, it can be seen in different ways. For example, we have the Easter search and then we have a greedy search. So for Easter, the algorithm finds the shortest path through this search space using the heuristic function, and then you also have a greedy search, and then you are going to go to uninformed search. Here the algorithms have no additional information on the goal node other than the one provided in the problem definition, so it consumes less memory space. But remember, here you don't have an idea of what you are going to make research about. So it includes the breadth first search, depth first search, and uniform cost search, and that's what I was trying to explain down here. For the breadth first search, a graphical traverse algorithm that starts traversing the graph from the root node and explores all the neighboring nodes. So this is always a complete search and returns the shallowest solution. This is about the BFS. It returns the shallowest solution always. Then you also have the depth first search. For this one, it's always incomplete if it involves cycles. That's the only disadvantage with this one, the depth first search, but still it can be applied. Then the uniform cost search, this is always complete and optimal, and this is what anyone could opt for in this kind of search online, because it is always such that if someone starts to search for any kind of product, you are well conversant and sure that you will get what you're searching for online, other than the other first two. And then we have the AI accountability. According to our project, accountability refers to the expectation that organizations or individuals will ensure the proper functioning through their life cycle of the AI systems that they design, develop, operate, or deploy in accordance with their rules and applicable regulatory frameworks. For demonstrating this through the actions and decision-making process. For example, by providing documentation on key decisions throughout the AI system life cycle, or conducting or allowing auditing where justified. So in the case of the online trading, accountability can be applied in finding out how many customers visit a particular website. Okay, just trying to find out accountability at the end of the day, how many people visited the website to order for different products. Then according to the views, if the system allows, it can maybe, if customers are allowed to give their views after making their orders, like to give their views, the challenges they face, maybe to comment on the good things they can find. So you find that basing on the views, the product seller can base on that to improve on where errors are made, or where maybe the system may be down, or to improve on the quality of the products. And then accountability can also enable the one selling the products to calculate both the profits and losses basing on how many people have ordered for particular products in a given day. So that's still about the accountability. Just having an overview of what has been taking place in the whole system, like as customers interact with the system, you find out the views from your customers, like feedback to help you to improve on your system or to improve on the products in order to enable smooth running of the system. So that's what I had for today. Thank you very much for listening.